So this is going to be our part 2 video for Newton's second law of motion. So in this example, we're going to start looking at the carts and the weights and the pulley systems that are in your textbook. So these examples are a little bit longer. So if you haven't already reviewed or you're not comfortable with the easy stuff for Newton's second law of motion, please review that video first. So we now need to talk about our force due to gravity. So our force due to gravity is equal to our mass times our acceleration due to gravity. And that acceleration due to gravity is different everywhere, but on Earth, we use 9.8 meters per second. So anytime we need to calculate our force due to gravity, we're going to take our mass times it by the acceleration due to gravity. And so just so you know, that's actually what we call our weight. We often say that we weigh this much, but we really should be using the term mass. Because if you take your body and you bring yourself up to the moon, well, this G value is less. And so your force due to gravity, your weight, is different. So really we should be using the term mass, but we often use the term weight. So here's our example. So we have a cart that's on a table. There's a string, and we're going to assume that the string weighs nothing. And it's through a pulley, and then there is a hanging mass. So we're going to assume no friction. There are some examples in your textbook where you do use friction. So part A is the long part of this question. Okay, so determining the magnitude of the acceleration of the cart. So we have two objects. So what we're going to do is we're going to draw a free body diagram for our M1. So our mass 1 is equal to 0.85 kilograms. So that's important to keep in mind. So let's draw our free body diagram. So we have a normal force and a force of gravity. Those for our cart, because they are on a table, are equal. And then we don't have an applied force here. We have a tension force. Because remember, a tension force is any time you have a string involved. So let's write an equation for our F net. So again, our normal force and our force of gravity are equal. So our F net is equal to our tension force. And in Newton's second law of motion, anytime you see F net, you can replace it with MA. So that means for the cart, the force of tension is equal to the mass of the cart. So I'm just going to add the little 1 there, times the acceleration of the cart. So we're going to use this information, but we're going to leave this for now. So this is our equation 1. I'm going to change my color so that we can keep track of our different things. So now we're going to do our M2. So our mass 2 is our weight that's hanging, or our mass that's hanging down here. So let's draw a free body diagram. So we don't have a normal force here. We have a tension force. So there is still a normal force, but really we are not going to worry about that. We're just going to worry about our tension force. And then we have our force of gravity. Okay, so we have no horizontal motion. So that's what we've got. So then we're going to write a F net equation. That's always your goal here, is to write an F net equation. The force of gravity is going to be stronger than the force of tension. So we're actually going to do Fg minus Ft. Okay, so now remember, anytime you see F net, we can replace it with MA. And anytime we see Fg, we can replace it with Mg. Okay, so by doing that, we have these two equations. So this is our equation 2. So I'm going to flip to a clean slate so that I can write a... And so I'm going to rewrite those equations. So our equation 1 was M1 times A. Sorry, I erased that because it was starting to get a little messy. So M1 times A equals our Ft. So that was equation 1. Equation 2 was M2A equals M2G minus Ft. So those were our simplified equations. So now, think way back to grade 10 math when you learned solving by substitution. So we are going to sub equation 1 into equation 2. So I'm just going to start writing down my second equation. And when I get to my minus ft, instead of writing ft, I'm going to put m1a, because we said that our tension force up here in equation 1 was equal to the mass of 1 times the mass of 2. So we're going to go ahead and we're going to put our information in. We're not going to put units because that starts to get a little confusing. All right, and then we're going to keep simplifying. So 0.5 times 9.8 is 4.9, and then we get this. So then I'm going to move the negative 0.85 over to the other side, which means I'm going to be adding it to my 0.5. So I get 1.35a equals 4.9. And then we divide both sides by 1.35. So we get, we're going to round it to 2 sig figs, so 3.6 meters per second squared. And we're talking about the cart here. So the cart is moving forward. Okay, so for our direction, we're going to use forward. So that's part A. So you can see part A is pretty long. Part B, though, is quite a bit shorter. So part B asks us to calculate our tension force. So you can use equation 1 or equation 2 to solve for Ft. I'm going to guess that most of you would choose to use the first equation, mainly because it's shorter, which is fine with me. So we're going to do Ft is equal to our mass. So our mass there was 0.85 kilograms times our 3.6 meters per second squared. So our Ft, again, we're going to round it to 2 sig figs. So we get 3.1 newtons. And for the cart, it's forward. For the mass hanging down, it would be up. That would be our tension force. But generally, we're being asked to determine stuff for the cart. So we would say that it's 3.1 newtons forward. So that's it for a review of Newton's second law of motion. Hopefully things make a little bit more sense. Again, there are lots of tutorials in your textbook to help you out. So have a look at those too. They solve things a little bit differently than how we did, but you get to the same result.